Testing the simple machine class results. So first thing I want everyone to look at is the lever, okay, from the lever, which should be, I believe, the first page in your packet. So what I want you to do is tell me how many newtons of force did it take to move the load by hand for everything. What did it take, Myra?
5.5 newtons.
Very good, 5.5 newtons. So I'm going to write that in, 5.5 newtons. Now, scale readings, okay? How many newtons of force did it take to move the load with a simple machine? So dash 1, what about lever position A? What did you have?
3.5 newtons.
3.5 newtons. Somebody have something different? Sarah, what did, you had the same? Monique? 4 newtons. What did you have?
I had 3 newtons.
3 newtons.
4 newtons.
You had 4 newtons for lever A. Same as Jada, okay? So we kind of had 3 and 3.5 and then 4. So if we kind of, again, go in that middle, the median one, that would be that 3.5. Very good. Newtons. How about the position B? What did you get for position B? Beyonce?
7.5.
7.5. Monique?
6.5.
6.5. Myra?
6.
6. All right, so we had all these different things. What do you guys think looking at our class data now, if I look at it all together like this? What do you think would be maybe the easiest simple machine? What's going to make the work the easiest? Which simple machine? Zaire?
I think the wheel and axle.
Good. And why do you say the wheel and axle would be the easiest?
Because it wasn't even like pushing anything, because it was 0 newtons. No survivors at all.
Yeah, it had 0 newtons, right? So you essentially weren't really using any force. You weren't really doing too much work at all, were you? What were you going to say, Beyonce?
Because the wheels are helping you.
That's right. The wheels are really doing the work for you, aren't they? Aren't they?
It's like ergonomics.
And ergonomics comes into play. We're going to talk about that in a second. Myra?
It depends on what the job is.
Okay, what do you mean by that?
Like if you had to transport it from across the room, the wheel and axle would do the rest of it. But if you had to pull it up somewhere, then the pulley would do it.
Okay, so we have to look at our jobs that we're going to actually be doing. You're absolutely right. So what do I have to do with the load? Do I have to lift it up off the ground, or do I have to move it from this position to this position? That's a good point. So you said the pulley. Which pulley?
Double.
Double. Okay. So why do you automatically say the double before the single pulley? Why?
Because the double is 2 newtons and it's less than 5. And if the load by hand is 5.5 newtons and the single pulley is 5 newtons, it's just like you just lose a half force, so you're just doing just about the same amount of work.
For which one you're doing the same amount of work if you use the single versus by hand? Very good. Okay. So you're absolutely right, because the single pulley, now let's take a look right now in your packets and flip to the pulley. Flip to the pulley page in your packet, because I'm going to look at this a little bit. I want to talk about this a little bit. Okay? With the pulley, who can read the question, the summary questions there at the top of that box on the packet? Who can read those bullets there nice and loud for me? Sharice, can you go ahead and do that?
Compare how many newtons of force were needed to lift the load using the single pulley and the double pulley. Now, think about how much rope you had to pull to lift the load the same distance using each pulley. What's the trade-off?
Very good. So, who can answer that? Who can read their answer? Daishwan, what did you have down for your answer on that one?
The double pulley was easier than the single pulley, and it was a 3 newton of a difference.
Okay, so the double pulley was better than the single pulley, and the difference was what? 3 newtons, is that what you said? 3 newtons.
The trade-off is the more strain or less load.
Okay, so I want to kind of write that down. I want to talk about this a little bit. Because that trade-off, that kind of had me confused a little bit. Raise your hand if it had you confused a little bit when we talked about what is trade-off. What is the trade-off? All right. So you told me, Daishawan, that the trade-off for the single pulley versus the double pulley, is that what you're saying? Okay. So using the single versus the double pulley was what? Can you read it again, that last part?
more string and less foam.
Had less force? Okay, so again then, Daishuan, when we're talking about that trade-off, you said I have to use more string, okay? So when you pulled down to lift it up, using more string is a greater what? Think of measuring. Length, a greater
Distance.
Very good. Okay? So using more string was kind of a greater distance, right? That string had to travel. So I'm just going to kind of write that in parentheses. Okay? And then you had less force, or you used less force, right? So because I had to travel a greater distance with a string, that really made the force, my newtons, much less, right? So it made the work a little easier, didn't it? So again, if I have greater distance, then I use less force. Is there another one that was similar to this, where even though I had to go a greater distance, it still was less force? Is there another simple machine like that, Alina?
That the greater distance that use less force works for the inclined plane too, because the short board you have to use more newtons because you have to make sure that it reached all the way to the top without it falling off. But the long board you could just simply just pull it up without having to worry about really anything.
Very good, very good. So the inclined plane, the short board, right, there's our distance. It's less distance, but we had to use more force. The long board, longer distance, right? Greater the distance, less force. We can actually look at this, and what I want you to do at the bottom of your packet, on either the front page or back page, it's up to you, as long as it's on your packet, we have a little formula for work. I want you to write this formula down, okay? Work equals whatever the force is times the distance. Does this look familiar to you guys at all?
Yeah.
Yeah. You remember that little Simple Machines video in United Streaming that we did? With the old guy in glasses? What was it? So he was talking about how force, whatever force you're using, times the distance, right, is going to equal how much work, right? Work it is. Okay? Right. So if I put more on this side, right, of my equation, right, more force, I have to have less distance. And then the opposite, right? So it's like a balance. It's like a scale. When we do lesson 3, and the main key components that I want the students to take away from is knowing how the simple machines work, knowing how force and distance come into play with all the simple machines, with the equation of the force times distance equals the work, and using their scales for their newtons about how the scales and the newtons will come together, showing the force that was needed to use each simple machine and showing the difference with the comparisons. Looking at that, and you guys just mentioned some of the simple machines that you thought, just from looking at our data now as a class data, you said the cart, the wheel and axle, and the double pulley seem to be the best simple machines as far as making work the easiest. And plus even easy with our ergonomics, the motion that we have to do. Very good. So we talked yesterday about if you were to build something and build your own little factory subsystem, just like Aisha did in the story, what would you use? Who can raise their hand and tell me what were your predictions from yesterday that you, or not predictions, but what you would use if you were going to build something? Yeah. Okay, so the inclined plane, the long board or the short board? Long board for the inclined plane and the wheel and axle. That's what she would want to use. What would you use, Daishuan?
I would use the pulley, the double pulley, and the inclined plane.
And the inclined plane. What would you use, Myra, if you were going to create a factory subsystem?
I said to get the potatoes to the other side. from the truck, I would use the wheel and axle with the wheels, and then I would take on and then I will use an incline plane and trip the thing, and it will go up. It will fall down the incline plane to the pulley, and then I'll have to pull it up, and that's it.
Okay. Good. Very good. And and I'm glad you guys are relating back to the story about the bag of potatoes. I think the students love lesson 3 because it's their hands-on part. Anytime that they can do stuff together in groups and play around with anything, which these are similar to, I guess, toys at times to them. But so any time that they can do that, they love doing that. So luckily with lesson 3, they jump right into it. They don't really have too many complaints. Only maybe things after the data analysis part might be their only complaint, where they have to come together and draw their conclusions. One of the things with lesson 3 that I definitely do, that the binder helps do, is breaking it down into 2 different parts. So I actually took it into 2 different days. In lesson 3 for day 1, what I try to do is introduce and do most of the introduction for it, talking about the vocabulary, talking about what work equals force times motion, or excuse me, force times distance, and making sure that they understand what the packet is asking them, the summary questions are asking them, and how to use each simple machine. So I try to take a child volunteer and help me with how it's going to look while they go around to these different stations, what each station will look like for the first day. And the second day focuses on that part 2 activity, where they actually are going and they're filling in the packets, they're doing the paperwork and actually working on the simple machines. So that way it kind of is a good stopping point, and that way that they can go to each station without me having to say stop and do half a rotation and make them do different stations, or remember which station you left off at to come back to the next day. It kind of makes it a more complete thought and a complete process for them.